Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Muhammad Rozi from DEM 3A. Register number is OTDEM 90F1037. Today I want to discuss about force vector. Okay, firstly the objective. The objective is to experimental verify the triangle construction of parallel diagram, law of vector addition by using force table. Number 2, to understand the basic concept of force vector. Number 3, to draw a force vector diagram. And number 4, to find analyze the resultant force and direction from the vector diagram. Okay, for the introduction and the theory, study of motion will involve the introduction of a variety of quantity that are used to describe the physical world. Example of such quantity include distance, displacement, speed, velocity, accelerate, force, mass, momentum, energy, and work, power, and other more. All these quantity can be divided into two categories, vector and scalar. A vector quantity is a quantity that is fully described by both magnitude and direction. On the other hand, a scalar quantity is a unit is to understand some fundamental about vector and to apply a fundamental in order to understand motion and force to occur to dimension. Not just that, vector quantity are often represented by scalar vector diagram. Vector diagram depict a vector by using an arrow draw to scale in a specific direction. Vector diagram were introduced and used in early unit to depict a force action upon an object. Such a diagram commonly called as free body diagram. An example of the sketch vector. The diagram is shown in the diagram below. The vector diagram displays vector. Observe that there are several characteristics of this diagram that make it appropriately draw vector diagram.
Mathematical method. The most common two-dimensional resolution of a force vector is into rectangular components where fx and fy are vector components of f in the x and y direction. So force in x-axis, fx is f cos 30, force is y-axis, fy f sin 30 cos, relation f2 fx2 plus fy2. Basic theory, resultant versus equilibrium. A point to be aware of is that force needed to balance the system is not the resultant of the weight but the negative of the vector, also called equilibrium. There are vector shows the resultant of the three vector f1, f2, and f3 vectors are in equilibrium and their sum is equal to 0 as shown. f1 plus f2 plus f3 equal to 0, or f1 plus f2 equal to negative f3, or fr equal to negative f3. This means that when the sum of the three vectors is 0, the resultant of n2 has magnitude equal to magnitude of the third one, and direction opposite of direction of that third one. Next is equipment and apparatus. Equipment, force vector. Force table, pulley, hanger, weight, string, ring, and protector. Procedure. First, prepare the tools and materials as shown in figure 1 below. Given three masses of 90 grams, which will be given at 112.5, 250, and 0. Hanging a mass of 90 grams, including heavy hanger, at angle mark 112.5, 250, and 0. Record each weight when placed on a weight hanger. Stabilize the heavy hanger so that the ring does not touch the middle part by moving the string, so the ring does not touch the middle part. After the record is stable and calculate all the forces acting on the x and y axis. Next, repeat the same way with a weight of 110 gram at angle marked 239, 121 and 0. Record in the same way as table 1.
Hi, Assalamualaikum. My name is Ahmad Rahman bin Muhammad Aslan. I'm from DEM 3A and my metric number is 14 DEM 19F 1039. Okay, today we're going to talk about the result of the force vector lab report. Okay, table 1 is symbol 1. F1 is the mass is 19 gram. Okay, and the weight force Newton is 0.882 Newton, and the angle is 112.5. The angle action is CW. Symbol F2 is same 19 gram, and the weight is 0.8829, 0.8829. Okay, and the angle is 250, and the angle action is CW. Okay, the F3E symbol is 19 mass gram, and the weight is 0.6867 Newton, and the angle is 0, and the angle action is nothing. Okay, the table 2 symbol is F1 is F2 F1 is 110 gram. The weight is 1.0779 Newton, and the angle is 239. The angle action is CCW. Okay, the F2 is 110. The weight 110 gram. The weight is 1.079 Newton, and the angle is 121. And the angle action is CCW. Okay, the F3 is 110 gram, and the weight is 1.079 Newton, and the angle is 0. Okay, the angle action 0. Okay. Okay. Data analysis. Table 3. Okay. Force is F1 is 0.8829 Newton, and the direct action is 112.5. Now the magnitude force on x-axis is negative 0.3379, and while the magnetic force on y-axis is 0.8157. Okay, the F2 is 0.8829, while the direction is 250. The magnetic force on x-axis is 0.3019. Okay, the magnetic force on y-axis is negative 0.8297. Okay, the F3 for the force is 0.64. The direction is 1.25. Okay, the magnetic force on x-axis is negative 0.63998. The magnetic force on y-axis is negative 0.0414. Okay, the magnetic force on the x-axis for the fx is negative 0.6398. Okay, the magnetic force on y-axis is Fy 0.014. Okay, for the table 4. Okay, table 4. Okay. The force F1 is 1.0791 Newton. Okay, the direction is 239. The magnetic force on x-axis is negative 0.5558. The magnetic force on y-axis is negative 0.9240. Okay, for the force F2 is 1.0791. Okay, the direction is 121. The magnetic force on the x-axis is negative 0.5558. Okay, while the magnetic force on y-axis is negative 0.9240. Okay, for the R and for the R3 is 2.1566. Okay, the direction is 58.97, and the magnitude force on x-axis is Fx negative 1.1116, and the magnitude force on y-axis is negative 1.8848, and the Fx is negative 1.1116, and the Fy is negative 1.848. Alright, that's all. Thank you.
Hi, Assalamualaikum. My name is Nur Faradiba binti Nordin. I'm from DEM 3A. My register number is 14DEM19F1031. So right now, I will tell about the discussion. In this discussion, we need to draw the first diagram. So this is the first diagram, and you can see here is the first diagram. So the diagram is a parallelogram because the shape is like a kite. After that, we need to find the resultant force and direction. To find the resultant and direction, we need to find the Fx first and Fy, and then we can find the resultant and direction. For the Fy and Fx and Fy, formula to find the Fx and Fy is depends on the table and the force. So for this diagram is F1 cos theta for the Fx, and for the Fy is first sin theta. For the F1x is 0.8829 cos 112.5 degree. So the total is negative 0.3379. And for the F1y, F1 sin theta, 0.8829 sin 112.5. The equal is 0.8157. For the F2 is 0.8829 cos 250 degree. The equal is negative 0.302. For the F2y is 0.8829 sin. Okay, after that, we need to find the Fs and Fy. To find the Fs and Fy, we need to plus the F1 plus F2, and then we can get the Fx and Fy. So for the Fs is negative 0.3379 plus negative 0.302. So the equal is negative 0.64. For the Fy is 0.8157 plus negative 0.8297. The total is negative 0.014. To find the resultant, the formula is square root Fs square plus Fy square. For the table, for the resultant is square root negative 0.64 square plus negative 0.014 square. The equal is 0.6402. To find the direction, the formula is tan theta equal Fy per Fs. For this table is tan theta equals negative 0.014 per negative 0.64. So we get the tan theta equal 0.0219. So we need to move 10 to the right. So the equal is theta is 1.25 degree. For the table 2 is we still use the same formula, still use the same step. So firstly we need to find the fx and fy. So for the table 2, f1 is 1.0791 cos 239. So the equal is negative 0.5558. This is for fx, and for the fy is 1.0791 sine 239. So the equal is negative 0.925. For the f2s is 1.0791 cos 121. So we get negative 0.5558. And for the f2y, 1.0791 sine 121, we get the negative 0.925. So after we get the f1 and f2, we can get the fx and fy. For fx and fy, we need to f1 plus f2. So for the fx is negative 0.5558 plus negative 0.5558. So the equal is negative negative 1.1116. And for the fy, negative 0.925 plus negative 0.925. The equal is negative 1.85. So after we get the fx and fy, we can get the resultant. Formula resultant is square root fx square plus fy square. So for resultant is square root negative 1.1116 square plus negative 1.85. The equal is, so the equal is 2.1583. To get the direction is tan theta equal fy per fx. For this table 2 is tan theta equal negative 1.85 per negative 1.1116. So after we move the time to the right, we can get the direction. So the equal is 59 degree for the direction. So the conclusion is, when we place a mass on fourth holder equal to the magnitude of the resultant, the ring turns to equilibrium. That means the force of the fourth mass is equal to the resultant force of the first three mass. For this force vector, we have a source of error. So the source of error is some magnitude of vectors are demicurls, but we only have the mass with whole numbers. Second, some masses are rusted, so their mass by higher or lower than the standard. Lastly, our table is not horizontal, so our directions of vectors are little fierce. So that's all from me. Thank you.